Hi, welcome back. In this lecture, I want to introduce the profiling activity that we're going to use during this course. So I will define what profiling is and how to use it in the codes. By the end of this lecture, we will be able to defining profiling and state why profiling is important in high-performance computing. We will be able to describe which part of the computing system can be profiled. We will be able to understand that profiling comes always with a little bit of overhead. Finally, we'll be able to list some profiling tools in Python that we are going to use during this course. First, what is profiling? Profiling is the measure of our program performance to find performance bottlenecks. So then we can do the least amount of work to get the biggest practical performance gain. In practice, when we work on a code, we focus only a very specific part of the code, on that part of the code that takes most of the time, and then we optimize it. Profiling allows us to make the most pragmatic decision for the least overall effort. What does it mean? This means that if we have a code, we first decide which part of the code can give us most of the performance. We optimize it specifically on that part of the code. A part of the code that takes a little bit of time, even though it's inefficient, if we optimize it, is not going to have a big impact. So profiling allows us to have this pragmatic approach to optimization. We first measure what is the part of the code that takes most of the time, and then we optimize it. Example of the profiling and optimization process are if a program running too slow or using too much RAM, we want to fix only the parts of the code that is responsible for it. We don't want to fix everything, right? If we know that memory is a problem, we just want to identify the part of the code that is the issue and fix it. It's important that before doing any optimization work on our code, we do hypothesis. So we do hypothesis before making changes to the structure of our code. Why profiling is important? Well, we can of course skip profiling and we fix what we believe might be the problem. It turns out that our tuition, especially when it comes to optimization, is often wrong. So we ended up in wasting some time and fixing the wrong thing. So rather than using our intuition, it is far more sensible to actually define first some hypotheses. So we use our intuition to say, well, I believe this part of the code is going to be the part that it need to be fixed, that need to be optimized. So we define an hypothesis on where our code is slow and what expect from the profiling information. After we define this hypothesis, we profile the code with timers and other tools, the so-called profilers. Finally, after we analyze the data coming from the timers and the tools, we make change to the code. So we change the code and observe the performance improved or not. So we validate or not our hypothesis. What we can measure in our code using profiler and timer? Well, it turns out that we can measure pretty much anything. So any measurable resource can be profiled, not just the CPU. So we can of course profile the performance of the CPU, for instance, execution time. However, there are tools to analyze the performance of all the different computer system components. So this goes from the usage of caches to the usage of the main memory, in particular of page faults, to timing, what is specifically the workload of a function. Of course, most of the time we will focus on both CPU time and memory usage. However, many other metrics can be used. So we can apply similar techniques to measure network bandwidth and disk I/O bandwidth and latency too. So the first aim of profiling is to test a representative system to identify what's slow, or using too much RAM, or causing too much disk I/O, or too much network communication. It's important to realize that any performance optimization is often very specific to a given architecture. So an optimization for a given architecture might not be the same for a different architecture. Somehow, all the optimization work is not portable. So whenever we want to do an optimization work, we want to improve the performance of our code, we need first to target a specific architecture. That's why in your HPC assignment, we always ask you to specify which system are you using and what are the characteristics of your system. So when we do optimization, since optimization is not portable, it's often useful to profile the code on different systems. So to see how different computer system components are stressed using different architecture. For the sake of this course, one system is enough, but as a professional, often we have to deal with 2-3 systems. Do the profiling, check where the performance is missing, and then compare also the performance information we get from different architectures. A very important part about the profiling is really to understand that profiling should not be used on production code. So when we do a big simulation, profiling should not be on. And the reason why is that profiling adds quite a lot of overhead. If our code takes 1 second for just without any profiler on, it might take 10 seconds, 100 seconds, 2 seconds, just because the profiling is on. So it's important to notice that profiling typically adds 10 times, 100 times the slowdown. And that's quite common to observe in all our profiling runs. So we use profiler only just for optimization, and we turn it off for a production run. In many cases, when we have a big code, we also want to extract a test case and isolate pieces of the system that we need to test. So we don't profile the whole things, but we do some tests, profiling certain part of the computer system, for instance, memory, and then we perform the profiling and optimization. I want to list a few tools that we're going to use in this course for profiling our code. Of course, the first and probably most important is to use a timer function. For instance, we're going to use the time methods from the time module, and also a decorator from Python. We're going to look at cprofile, that is a built-in tool to understand which function in our code take the longest to run. This will give us a high-level view of the problem, so we can direct our attention to critical function of our code. Then we're going to more fine-grained profiling tools, that is the line profiler, that will include also a count of the number with the times each line is called and the percentage of time that is spent on each line of our code. We're going to look at how to profile memory usage using a memory profiler. We're going to look at the tool to look at the processes and the usage of different computer system parts by different processes called PySpy. And finally, also, we're going to look at some tools to analyze the low-level code that is generated by Python interpreter. To summarize this lecture, profiling allows us to measure our code performance for different computer systems. Turns out we can profile pretty much anything. Why we do profiling? The reason is that we want to pinpoint part of the code that should be optimized, the so-called computational bottleneck. We can measure several performance metrics, going from the usage of processor, memory, to the I/O and the network. It's important to note that profiling comes with an overhead, typically of 10 times, 100 times, but can be less or can be more. So it's important to turn it off when we do the real production runs. Finally, we saw very quickly that there are several tools that are available for profiling the system, profiling the code, and measure performance of our code. This is the last slide. Talk to you soon.